theorem 2 states that if we have limit z tends to z naught f of z equal to omega naught and limit z tends to z naught capital F of z equal to w naught, then the limit of their sum f of z, small f of z plus capital F of z, that will be omega naught plus w naught. So this is same as real analysis, and the same results, these are the results analogous to the results in limit rules in real analysis. So these things can be proved easily by adopting the same way of the proof we discussed in real analysis. So for the if we assume these two things, we have the definition for every epsilon greater than 0, there exists delta 1 greater than 0 and delta 2 greater than 0 such that modulus of f of z, small f of z minus omega naught less than epsilon or epsilon by 2 whenever mod z minus z naught less than delta 1 and modulus of capital F of z minus w naught less than epsilon by 2 whenever modulus z minus z naught less than delta 2. Okay, so this is the definition of the first two limits. Now we need to prove that the sum tends to omega naught plus w naught. Okay, so we start with a modulus of small f of z plus capital F of z. Okay, so this minus. Okay, so this minus z minus w naught plus omega naught plus w naught. So this is by using triangle inequality, this can be made less than or equal to small f of z minus omega naught plus capital F of z minus w naught. Okay. And this is less than epsilon by 2 plus epsilon by 2 whenever this is in fact epsilon, whenever modulus z minus z naught less than delta, where delta is equal to minimum of delta 1 and delta 2. So this proves the first rule. That can also be considered called as sum rule of limit. Okay. Now we prove product rule. So the product rule states that this small f of z times capital F of z, this tends to omega naught times w naught. Okay, we will prove that this will be less than epsilon whenever modulus z minus z naught less than some delta. Okay, so this is what you have to prove the next. Okay, so this is. For this we write small f of z equal to u plus iv and capital F of z is equal to capital U plus I capital V, and suppose we consider this omega naught, which is the limit of small f of z, that is small u naught plus iv naught, and w naught as the limit of this capital F of z, so that is u naught plus I v naught. Okay, if you replace all these quantities using u and v, then what is this small f of z times capital F of z? This is by performing the term by term product, u plus iv times v plus iv, you will get this product as small u capital U minus small v times capital V plus I times small u times this is small u times capital U, small u times capital small v times small v times capital U plus small u times capital U. So this is obtained by term by term product of this and this. Okay, so you can easily get the real part is real part of f of z, small f of z into real part of capital F of z and minus of the product of the imaginary parts. Okay, and you can easily get this expression. So do it an exercise, small f of z into capital F of z, that you take this one and you consider omega naught and w naught. This is again from the product of these two quantities, this and this. Then that will be the same thing, u naught, small u naught, capital U naught, small v naught, capital V naught plus I times small v naught, small u naught, capital U naught, small u naught, capital V naught. Okay, so this is these two things. Okay, and then you can write this as we know that whenever this f of z, since this f of z tends to omega naught, that means if this tends to this thing, we can say that u tends to u naught and v tends to v naught. Okay, so we know that u naught or u v, this u capital U tends to u naught because this small u tends to u naught and capital U tends to this capital U naught. Okay, so we have this result, and similarly we know that capital V tends to V naught, capital V naught, and U tends to V naught, capital U naught, and finally this U naught, sorry, V tends to U naught, V naught. Okay. That is f of z converges to omega naught means the real part and imaginary part tends to u naught and v naught. Similarly, capital F of z converges to this capital W naught means the real part capital U converges to capital U naught and capital V converges to capital V naught. So the corresponding convergence will be there. So using that fact, you can easily prove that once you consider the product, we know that this is the product. So whenever this f of, in order to prove this f of z, capital F of z tends to w naught, omega naught, w naught, we need to prove this limit. Okay? This quantity tends to this one. Okay, so we start with that u capital U minus v capital V plus I times v u plus u capital V minus this product u naught capital U naught minus V naught capital V naught plus I times V naught capital U naught plus U naught capital U naught. Okay, so this. Okay, we need to prove this these two quantities. Okay, the difference between these quantities is less than epsilon. So this is less than epsilon. That is because we rearrange these things u capital U minus v capital V minus this thing u naught capital U naught minus V naught capital V naught plus I times V U plus U V this minus right, this is V naught U naught plus U naught V naught. Okay, also this, and we know that this thing converges to this because of these things. We know that U tends to U naught capital U naught, V, capital V tends to V naught, capital V naught. So using these things, etc. So this using considering or applying these limits here, we can say that this modulus can be made less than epsilon by 2. So we use trend inequality to write the modulus of the first two quantities plus modulus of the second term. Okay, second two the last two quantities. So this first quantity will be less than epsilon by 2 and this is less than epsilon by 2 because of these limits. So this is made less than epsilon, okay, which proves the product rule of limit. Okay, next we will prove the quotient rule, f of z divided by small f of z divided by capital F of z. So in order to prove that, we need to consider f of z divided by capital F of z minus omega naught divided by w naught. We need to make this is less than epsilon. Okay, this is what we have to prove. To prove this, we consider the two quotients f of z by capital F of z, w omega naught by w naught. So by simplifying or rationalizing this quotient, you will get these are the form for small f of z by capital F of z and omega naught by w naught. Okay, so in order to prove this, we will prove that this quantity tends to this. But we know that this quantity u plus v tends to plus I times v u minus u v, this minus this thing, okay, divided by u square plus v square minus similarly u naught plus v naught, capital V naught, plus I times v naught u naught plus minus u naught, capital V naught, divided by u naught square plus v naught square is less than epsilon, because we know that u tends to u naught and v tends to v naught and capital U tends to capital U naught and capital V tends to capital V naught. So all these, by taking all these limits, you can easily prove that this difference is less than epsilon. And we are given that this w naught, which is equal to u naught plus iv naught, this is non-zero. Therefore, the denominator never be zero. Okay? So which allow us to discuss these quotient, difference of this quotient will be for getting less than epsilon. Okay, so this proves the quotient part. Okay, so this is because of the components. Okay, so using theorem 1, the limits of the components, you can easily prove the rules. So the first one is called sum rule, the second one is called product rule, and the last one is called quotient rule. Okay, so in the next class we will discuss section 18 that deals with continuity. The only difference between the continuity and limit is we can replace the limit L by the functional value at that point. Okay, so all these things can be replaced in continuity by replacing the limits by the corresponding functional value at that point. Okay, thank you.